Good afternoon, everyone. So, as David said, I'm going to do more of a sort of generic introduction to cube technology. I want to talk about some traditional approaches to software development, why cubes are different, what are they good for, what are they bad for, how you go about choosing a particular platform, and then how you would design a good cube. And then I'll talk about some example applications that we've done using cubes, what we learned from that, some of the positives and negatives that we've learned as we've gone through this process. And if I've got time, I might just give you a little sample demo of a particular cube, just to give you a feel for exactly how you would use it as a user and the flexibility of it. So I'll start off with just talking about a traditional approach to software development. So what you would typically do is you'd get data together. It's all about the data. So you've got to gather a lot of information. So you've potentially got multiple trading systems. You might have curves, market data, static reference data. So you've got to get all that into one place. And then traditionally, you've got to actually make computations on that data. So you've got to perform computations in either stored procedures or software batch cycles. You've basically got to read data, calculate results, and then write it to a database. So that's a traditional approach to software development. And what that means is you have to know in advance what you want to see. So you've got to know up front what problem you're trying to solve and how you might want to look at that data. And then when you visualize the results, you would have typically static reports, things like forms and grids, a lot of web grids and that kind of stuff. So that's how you specifically, do a traditional kind of software development, and that's what we did for many years in the past. So I guess some of the issues that we learned from that was, first of all, batch processing. It takes time. You've got to do it overnight. It might take 2 or 3 hours. If you're running a 24-hour business, then typically, when do you do those batches? Maybe you've got multiple batches during the day. What happens if something goes wrong? If the batch fails with some bad data, potentially you've got 3 or 4 hours before you can recover. And that means potentially you've got no data for the day. Your day's lost, basically. And this process where you're actually writing all this data, you're exponentially using disk space. The more data you want to report, the more disk space you need, and it's an exponential thing. As your business grows, you've got more data. Maybe you've got all the historical data, so as you go through time, it's just incrementally building up. So you have a lot of issues around disk space, and you need a lot of hardware for that. And the more data you've got, the slower it becomes. You've got to read that data back out onto the screen, and it's slow. And then reporting, we all know, everybody wants reporting, and you never know in advance exactly what reports you want. So you get to a situation where, you've got to go back to your IT, internal IT, or your vendor, build me this new report. You've got to write a spec for it. It takes time. You've got to test it. Then a week's gone by, and you haven't got anything. So you can't really react to change quickly, and you lack flexibility. If there's a new regulation or you trade a new product, again you might have to change your batch cycles. It's always a very slow process. And the other thing we learned is that you end up with all these batches. You end up building a lot more system software. You've got more bugs. The more system software you write, the more potential you've got to have system bugs. The higher the maintenance cost of those systems. You've got to have people on standby overnight, watching these batches. So that's kind of what we learned from our previous days, is that it's not straightforward. There's a lot of pitfalls, and the users typically don't get what they want. So that's really where cubes came in. Now, a cube in a particular sort of sense is a three-dimensional solid object bounded by 6 square sides with 3 sides meeting at each vertex. It's quite a mouthful. But actually, in terms of what we think of as a cube, in technology terms, that's actually wrong, because here it's saying a cube is a 3-dimensional object. Well, actually, OLAP cubes are multidimensional, and by that we mean you've got specifically a lot of data in this cube, which we call facts or measures, and you've got a lot of dimensions. So you can slice those numbers in many different ways, and the idea is you you on the fly determine how you want to view that number. So you might have an overall portfolio number of P&L or mark to market, and you might want to look at it by customer, you might want to look at it by product, by time. Now, these are all dimensions, so that's where you get this concept of a multi-dimensional cube. And the other key thing there is that all the calculations that you make on that cube are done on the fly. There's some pre-aggregation, but ultimately when you ask the question, it computes the results. So that means you don't have to know in advance what the question is. You don't need to know up front what kind of reports you want to write. And that's a key element, flexibility, to be able to look at the data and slice it in any way you want. And obviously, the fact that it's a cube means you can do that in a really quick time. If you had a regular database, you know, on a million transactions, there's no way you could, in real time, run a query and see results. It just wouldn't work. So, and OLAP as a technology, or cube technology, is not actually new. It kind of started back in the 70s with a language called APL. So that was the first kind of multi-dimensional language, if you like. So it goes back, you know, that's 40 years ago. I mean, the 80s is where it became a bit more productized. You had spreadsheets. In a way, a spreadsheet is an early kind of version of a cube. And when Microsoft introduced pivot tables into Excel in the early 90s, that is really, you know, you could conceptually think of that as a cube. You know, you imagine you've got this data and then you've got pivots and you can slice it in a number of different ways. And the problem with that, of course, is you've got all this data in a spreadsheet. You've got multiple versions of that spreadsheet. You know, there's no security. You're copying it around the organisation. It's, you know, there's, you know, a lot of problems with Excel as a tool for actually slicing data. But it's quite a powerful tool, and it does give you a lot of flexibility. But it wasn't really until, I think, the late 90s, sort of 2000 onwards, that we really started to get what we call real sort of high-quality OLAP solutions, so cube solutions. Microsoft introduced a concept called analysis services, so that can sit nicely on top of Excel and allow you to use pivot tables. Oracle released an OLAP tool as part of their Oracle 9 platform, which was the original Express, which was another early OLAP tool. And the other thing is hardware becomes less expensive and more powerful as you go through time, so you can actually cope with a lot more data. So that's kind of a sort of a history of it. But you know, it's not particularly new, but it's really recently that it's becoming a much more widely adopted technology. So what are the advantages of it? As I said before, it avoids the traditional computer cycles, which are error-prone and basically take a lot of time. Now, a key message is you're not writing the results to the data store. So if you want to look at your, let's say, your credit exposure by counterparty, traditional system, you'd compute all those trades, you'd write the results to a database. That's slow to write them into the database and slow to retrieve them. With a cube, you don't do that. All you've got in the cube are the trades and the dimension for counterparty, and you ask the question and it will compute the answer. And it's fast. I mean, it's typically, you know, in general terms, around 1,000 times faster than a traditional database query. Hence, you can actually do it on the fly. And as I say, the advantage there is flexibility. You can look at the data in a number of different ways. You wake up in the morning, I want to look at my data in a completely new way, you can do it in the cube. So those are the sort of main disadvantages. But it doesn't, you know, in a way, it doesn't solve every problem. I mean, cubes are not transactional systems, so they're not going to really capture data in a transaction, write it to a database and read it out. So you still need to get the data. Obviously, you've still got static data to capture as well. You've got to get the data into the cube. That's the key thing. And the other thing is, although it's a real-time calculation, it's not really, in a way, it's not completely real-time because you've got to query the data. That's a key point. It's not going to push data to you. So if your traders do a new position, it gets into the queue, but unless I ask to see what that position is at that point, I'm not going to know that it's changed. So that is, you know, something to bear in mind. It's a query-based technology. And I think the other point I do want to make about it is that, you know, getting the right design of a cube is fundamental. If you don't design a good cube, it won't perform. It won't do what you want. So you kind of, you know, you've got to know your domain, and then you can produce, you know, a good design for a cube. And if you do that, you will have a very powerful tool. So this is a Gartner slide, actually, on the number of vendors out there that actually do OLAP or Cube platforms. So this is the platform. This is not an application. This is basically, like a software language, C++, Visual Basic. It's a platform to produce something. OLAP is a platform to produce these cubes. And you can see there, this sort of top quadrant here are the real sort of market leaders and visionaries in this space. And Microsoft are in there. That's the one we chose. IBM, they do this Cognos. Oracle I've talked about. ClickTech are another interesting one. It's all sort of real-time in-memory cubes. So there's a lot of them out there. And some of them are very big vendors. Some of them are quite small, kind of niche players. But that just does show you that there's a lot of these guys out there. We actually, as a company, we chose the Microsoft platform. And I couldn't say that it's the best, but for us, we found it to be really, really solid. It's got industry standard MDX, which is a cube language. So that's the language that you actually use to query data on a cube and write cube calculations. Another, I think, really powerful advantage of the Microsoft platform is the integration with Excel and other Microsoft products. Excel as a tool is cube enabled. People love Excel. It's the most widely used tool in the industry, and you can point it at a cube, and you can start using the data. And I'll show you how you do that in the demonstration. And some of the other reasons we went for Microsoft, it is a big vendor. I guess it's a safe vendor. There's a huge amount of investment in this technology, and there's a clear roadmap for the next stages. They're spending a lot of money on this technology, and it's highly scalable. We've done we've done a lot of scalability tests in Intel labs. We've had billions and billions of data points in cubes, and it performs. And you don't have to spend huge amounts on hardware. It will run on some reasonable hardware. And I think the other thing we like about it is just cost. There's no additional license. You've got SQL Server as a database. It's just part of that product. So you don't have to go and buy an additional kind of an additional vendor's product to be able to run OLAP. So those were kind of the real things that we liked about it. So I thought what I'd do now is talk a bit about cube design, which is it's a huge subject. It's obviously vital for getting a cube that's going to work for you. The main thing is at the top there is what we call the ETL layer. That is extract, transform, load. So that's how data gets into the cube. And the key thing there is is quality of data, massaging it so that it's all consistent across different systems. That's always a big challenge. You've got many different trading systems and other sources of data. It's all got to be consistent. And that gives you what we say there is a single version of the truth. When you've got all your data in one place from your whole organization, that is a very, very powerful thing. And then the next stage is really what we call unified dimension modeling. So that's the real nitty-gritty of designing a cube. And you've got to have domain knowledge. You've got to know what your users want in advance. You couldn't just open up the cube designer and build something and it's going to be relevant. You really have to have domain knowledge. You've got to know what the end result is. You've got to understand the data relationships. And essentially that's how you build a cube. And there's lots of different relationships in there. There's calculations. It's going to aggregate numbers in certain ways depending on the need. If it's a position, you're just going to add it up. But if it's credit risk, you've got agreements, netting, you've got all sorts of things going on there. So that's all part of the design. And then another, I think, really key element to cube design is what we call partitioning and how data is refreshed. Now, if you imagine a particular cube, you might have positions that come in at the end of day or every 5 minutes, but you might have prices that are changing all the time. So therefore, you need different strategies of how data gets refreshed on the cube. And the concepts there, we can have ultimately a completely real-time refresh of data. So as a trade hits a database, it's in the cube. Or you might have situations where the data is processed once a day. So more like a scheduled process. And getting that design and breaking down the dimensions and measures that mimic the kind of needs of the users and the needs of the data refresh is key to the design and key to the performance. But ultimately, you've got to know in advance what your users are going to want. And then the other thing is, is scalability. As David mentioned in his presentation, there is a lot of data. And as soon as you start doing simulations, hundreds of millions become, billions. And I think as David said, there's mankind creates 150 exabytes in 2005, and last year it was 1,200 exabytes of data, which is huge amounts of data. So, when you think about cubes, how does it handle that? And again, partitioning is important. You can have multiple cubes, you can scale out across your infrastructure. And you're designing your cubes that, so they can basically handle these huge volumes of data with the queries. So, that is a key element of a cube, is it can handle a lot of data quickly. I mean, it's absolutely fundamental, and that is one of the key reasons why you would choose to use this technology. So some of the applications that we've done as CubeLogic, risk management, I think is a really good discipline for cubes, because it is about gathering data. It's about aggregating that data for different needs. For market risk, it's potentially about running simulations, Monte Carlo VAR calculations. And the other thing you think about is, the new regulations, things changing all the time. You need to react to that. So you need a technology that's going to be flexible. If you wake up one day, you've got some new requirements, Dodd-Frank, Basel II, Basel III, Basel IV. You've got to have that flexibility built into it. And it does give you the ability to do ad hoc stuff as well. As I'll show you in the demo, you can basically, as a user, you wake up in the morning, you open up your cube, and you can design and create anything you want with drag and drop. And you're not waiting hours and hours for it. So risk, we found, was a really good fit for cube technology. And another thing we've done is around positions, so aggregating all your trades, slicing those positions in different ways, by products, by markets, by time, by portfolio, managing hierarchies of portfolios, hierarchies of book structures. Cubes are very good at handling hierarchies, and then drilling down to the detail. Ultimately, the cube has the lowest sort of granularity in it, so all the trade positions are in there. You might want to look at it at the top level, at a portfolio level, but you can slice right down to the raw trades and have a look at them as well. So you've got the complete cycle. And the other thing here is it's a much more of a real-time situation here. I mean, credit risk is generally end of day. Obviously, positions are trading's happening all the time. You want to look at your P&L, your dirty P&L based on current prices. So the cubes are updating and refreshing all the time. And again, that's where the partitioning comes into it. And then historical analysis is another quite powerful thing for cubes here. Again, you imagine you want a complete audit trail of all your trading activity every day through time. You might have 10 years of history. You want to look at trends on that history, and you can imagine the amount of data that's going to generate. And it's huge. And if you've aggregated all those results and written them to a database every day, that's a lot of storage. And it's going to be slow to retrieve that data. So again, that's something where cube technology is really, really powerful. It's flexible. I can do ASAP reporting. I can perform time intelligence, averages through time. I can model all the different data. And again, what I'm really storing in the database are the raw trades and raw prices per day. And then the cube is basically recomputing what the position would be at that time, based on the logic that you've defined in that cube. So you're storing the minimum amount of data there. So I think history, that sort of history cube is a really powerful way of application for cubes. So I guess this next slide is really kind of what we've learned over the last couple of years working with this technology and producing these kinds of applications. I think the key thing really is knowledge is power. You've got to know what you want to do. You've got to understand the domain, and you then marry that with an expertise in cube technology, and that's a very, very powerful combination. You can do a lot of good stuff. And another thing, as we found out, contrary to sort of previous traditional approaches where we wrote a lot of system software, we wrote zero system software. So all the man days of effort that we use were all on writing business functionality. The platform is rich in terms of its system infrastructure. All you've got to do is write the real business nitty-gritty of what you want it to do. And because you do that, it's fewer lines of code. It's obviously going to be fewer bugs. And fewer bugs is obviously easier to maintain, and so on and so forth. So that's a good message. And I think another thing we've really found is this ETL layer is really, very, very vital to get that right, to get the data in consistently, and to get all the data. You have to get all the data, because if you don't have all the data, you don't have the complete picture. You don't have a single version of the truth. And then no batches means less maintenance. It's cheaper to run. You don't have to be looking at, hiring people to watch batch runs overnight and receive emails if they go wrong, and support calls and all that kind of stuff. That all goes away. But we also found that training was quite a key element to this. If you design a really functionally rich cube, there's a lot of power in there, but if the users don't understand it, then it's pretty much useless. So training is key. They've got to really understand the concepts. And then finally, I think something we learned was, you can't really take anything away. You've got to know in advance, what the design would be, because if you take something away, users have already used it, and it can be quite problematic. So it's back to the same concept: get the design right. And then I think what I'm going to do now is just show you just give you a flavour of how you might use some of these cubes, just to give you an idea. So I'm going to have to switch this over. Projector over. There we go. Right, so now I'm actually going to just open up Excel. So in terms of how you actually access the cube, there are a lot of different visualization tools out there. We've got our own kind of web grids and other type cube explorers. But again, Excel as a tool is just perfect. So I'll start off just giving you a brief intro using Excel. So here is a completely blank Excel spreadsheet. I can insert a pivot table. I can choose one of my cubes. So these cubes are on the server, the data's secure, it's all permissioned, but I'm able to use Excel as a nice sort of front-end interface into it. So if I just choose a particular cube, I connect to that, and then you'll see over here it's very similar to your regular pivot tables. So I've got what we call measures or quantitative values over here, and then I've got ways of slicing those values. So if I just take trade positions. So let's just say I want to see my overall mark to market of my portfolio. I can just check that. So there you go, there's the number. So it's obviously not massively interesting on its own, but now let's say I want to actually start slicing that down. So maybe I want to look at my mark to market per trade type. So I can do that. So there's my current live trade positions. Maybe I then want to actually look at it in a particular, maybe a particular currency. Let's report it in, I can drag that in. Let's show it in US dollars. I can choose that. So there's another dimension acting as a filter, so you can always filter the data down. And then maybe I actually want to compare it to yesterday's position and look at a kind of a delta position. So I can go to my history. So if I bring in the historical mark to market, that's going to come in there. And now I want to actually choose a time dimension to tell me what day of history I want to actually look at. So that's kind of like each day is a snapshot. So I drag that in. Choose a date. Let's just choose the day before. So that's yesterday. So you can now see my my mark to market today versus yesterday. So maybe I would just want to look at what the actual delta is on that. So I'll bring that in. So it's just showing me how my position has changed from one day to the next in a few short steps. I can also introduce some KPIs. So maybe, why has that position changed? Was it due to FX movements, price movements, or new trading, or trades disappearing? So you can see I'm using these things called KPIs now on the cube. And a KPI, key performance indicator, is how you might compare one number to another. So an obvious KPI here is a price move has caused this mark-to-market delta to change. But obviously there are other KPIs. It might be an exposure against a limit, or a particular threshold of change. If a mark-to-market changed more than a certain percentage, you might flag that up as there's something going wrong there. So that just gives you a brief, very simple report. But you can see from that, it's quite user friendly. I can basically create anything I want on the fly, and it's fast. I've got lots of trades in here, and it's split second to actually get at the data. So do now is just return to the final slide. What is that? Okay, let's go for... I've got one more slide, which is the which is really, in summary, well, I guess this is sort of my top 5 reasons as to why to actually use this technology. And I mean, sort of harking on about this quite a lot, but performance, it has to be the ultimate #1 reason why to use cubes. People want data quickly. They've got a lot of it, and they don't want to wait hours for batches and then just minutes to actually run any queries. That's the key thing. I think flexibility is another really compelling reason to go for it. The self-service nature of it. I can create something on the fly as a user. I don't need to be technical to do that. I just need to understand what data's in that cube, and I can get it out. And the data analysis as a concept. All the data's in one place. You can look at it in many, many different ways depending on the type of user that you are. And there's no compromise necessary on the granularity of that data because of the scalability and the performance. I don't need to aggregate it up to a monthly level. I can see it as granular as I need to. And that, you're not going to compromise on granularity for performance. You don't need to. And I think the 4th reason for us, at least as a vendor, is less code to write. It's less to go wrong. It's more robust, cheaper to support. It's quicker to get business developments done and business applications written. It's faster. And then storage efficiency, as I said before. There's less data to write to the database. It's therefore cheaper. You don't need as much hardware. You don't need as much disk space. So that's the kind of that is in summary how I'd see it.